All right, let's put on our detective hats today. We're on a mission to solve a pretty fundamental chemical mystery. What is it exactly that gives acids and bases their unique powers? So here's our first piece of evidence. You've probably seen this reaction before. When an acid and a base get together, they neutralize each other. All that's left behind is a salt and some plain old water. But hold on. This just tells us what they do. It doesn't tell us how or why. What's their secret ingredient? What's the hidden identity that makes something an acid or a base to begin with? That's the real case we need to crack today. So, like any good detective, our first step is to look for a pattern, a common clue. We need to figure out what all acids have in common. Okay, time for our first test. The setup is simple. We've got a battery, a bulb, and a couple of nails dipped into a solution. The big question is, will this solution let electricity flow and light up the bulb? And boom, look at these results. When we use a solution of hydrochloric acid, the bulb lights up. But when we try it with a glucose solution, nothing. The circuit is dead. So what is this clue screaming at us? I mean, the acid is clearly doing something special here, right? It's allowing electricity to pass right through it. But how in the world is it doing that? The answer? It's all about ions. For electricity to move through a liquid, you need charged particles that can actually move around and carry that current. This means acids must be releasing these ions when they're dissolved. That's our first huge clue in this case. Okay, so acids make ions, got it. But are they working alone, or is there maybe a secret accomplice helping them out? Let's dig a little deeper with our next piece of evidence. So check out this next experiment. We've got dry hydrogen chloride gas, and we're testing it with dry litmus paper. And what happens? Absolutely nothing. Not a single thing. The litmus paper stays the same. This is a total game changer. Here's what our case file says. Basically, the acid molecule, HCl, can't unleash its power. It can't release that hydrogen ion, the H+, without its partner in crime, water. And here's exactly what's happening. That little hydrogen ion, the H+, it can't just float around by itself in water. No way. It immediately grabs onto a water molecule, and together they form this thing called a hydronium ion. That is the real source of an acid's properties. So you see, water is literally the key that unlocks the acid's power. So let's put it all together. The secret's out. Acids are just substances that release hydrogen ions, but only in water. And bases, they're the ones that release hydroxide ions, or OH- in water. The whole mystery hinges on water being there. Now, a quick but super important note for all you detectives out there. When you mix acid and water, it can get really hot, really fast. So remember the rule. Always add the acid to the water, nice and slow. Never the other way around. Trust me, you do not want that stuff splashing on you. Okay, so we've identified our main suspects, the H+ and OH- ions. But now we need a tool, right? A way to measure just how strong our evidence is, how acidic or basic a solution is, really. And that tool, my friends, is the pH scale. Think of it like a ruler for acidity, running from 0 all the way to 14. The lower the pH, the more acidic it is. The higher the pH, the more basic it is. Simple as that. And smack dab in the middle, you've got the number 7. That's our neutral zone. Think pure water. It's perfectly balanced. And this is where it gets really cool, because this scale is everywhere in our daily lives. Look at this. You've got super acidic stuff like the juice in your stomach, down around a pH of 1.2. And then on the other end, you have things like milk of magnesia, which is basic, up at a pH of 10. So, case closed, right? We figured out what makes acids and bases tick. But wait, the most important question any detective has to ask is, so what? Why does any of this even matter? Well, it turns out pH balance is, and I'm not exaggerating, critical for pretty much everything. Our own bodies, they have to stay in this super narrow pH range just to survive. You've heard of acid rain, right? That's just rain with a low pH, and it can be devastating for life in rivers and lakes. Even the food we grow depends on the soil having the right pH. It's a huge deal. So if you thought solving this chemical mystery was cool, and you want to get this kind of clarity on other Class 10 science topics, then you should definitely go and subscribe to the A1 Institute YouTube channel. We've got a ton more explainers just like this one to help you really get these concepts down. And we'll leave you with one final thought to chew on.
We just saw how something as simple as water can be the key that unlocks this incredible chemical power. So it really makes you wonder, doesn't it? What other simple, everyday things around us are hiding their own amazing secrets, just waiting for us to figure them out?